So we've done some definitions and describing what algebra is and talked about the building blocks of algebra. Remember that the language of algebra is really important if you want to be successful. So first thing, can anyone tell me how I know that a term is algebraic? Sure.
So there's like a letter.
It's right. That's all there is to it, right? If you have a letter in it, you know that something is algebraic simply because it has the letter. And can someone else tell me what those letters are called? Yes.
Variables.
Variables, exactly. Excellent. And they're called variables because their value can vary depending on the sentence that they're used in. Just like we ask what time it was, right? The answer varies depending on when you use it. Now, we still have number terms. And one thing that we didn't talk about was those are called constants. Can anybody think of why a number like 7 might be called a constant?
Because it is like a single number. It doesn't have like another number. It's not like a two number there.
So think of it like this, right? If there are 7 of something, would it be different if there are 7 apples or 7 pears? There's still how many of them? 7. So does the number 7 or the definition or the value of 7 ever change? No. But if you have 7a, where we have some unknown, then the value changes depending on what a is, right? So that's why numbers are called constants. Their value stays constant no matter what. Okay? So the value stays constant. So a 7 always means 7. Never can mean anything else, right? A 2 always means 2. Can't mean anything else. So you'll see constant terms. Well, today what we're going to do is we're going to talk about... Oops. That might not be the eraser there. There we go. We're going to talk about the idea of terms again. Remember, all terms have exactly how many parts?
4.
4 parts. Excellent. The first part is the what? Anybody remember? You can use your notes. Or you could look on the board because I've written it.
It's the sign.
The sign. Right. Those are the pluses and minuses. We can always tell where one term stops and the next one begins every time we see a sign. One of those pluses or minuses, right? What's the second part?
Coefficient number.
The coefficient, right. And the coefficient is simply the number part. Okay? And those two pieces are generally taken together, and what do they tell you about the term? Anybody else have your notes?
Everything.
It's the base.
What?
So what do the sign and the coefficient tell you, though? It tells you something about the term. It tells you how many of something you have, exactly. And that's an important concept, and that you're going to see why today. All right? And the third part of every term is its what?
Base.
Base. And the base simply means the variable part, right?
And a letter.
Okay? And the variables are the letters, which means that is the basis for everything that you do within algebraic term is that variable. Good. And then finally, whether you see one or not, there is an exponent or index, depending on the term you like to use. Doesn't matter to me. And these two do what about the term? They name it. They tell you what kind of term it is. Excellent. If you can get that terminology and you can see those parts working together, then you're going to make your life so much easier in algebra, right? So, and we'll talk about why that is. Yes?
Can you just explain coefficient?
Coefficient, that just means the number. So, for example, here's an example of an algebraic term.
Yeah.
What's its sign?
Minus.
And the coefficient?
4.
So we would normally just say the coefficient is a minus 4.
Okay.
What's the base?
The
A. And the exponent
is
the 3.
okay. So the
Okay.
exponent is what you actually carry out.
And so, but we can't really do an exponent on an A because, do I know what A is?
No.
No. So we just have to say it's A to the 3rd.
But the exponent is what you.
So all it's doing right now is just helping to name the term.
Okay.
And you're actually not going to have any exponents on this first set we work on. Okay? All right. So we have terms, right? They're the building blocks of algebra. But not all terms are algebraic. We also have what are called constants. But they're still terms. Okay? So today what we're going to do is we're going to talk about combining, and some books call it collecting. I don't care which one you like, is the one you should use. Oops, collecting, not collection. What are called like terms. Now, this is a concept that gives students problems, but it shouldn't really. If you think about putting something together, so let's say we have a desk, right? And we have a chair. Can I put a desk and a chair together to become a new object?
No.
No. But what if I have this one desk and this other desk?
Yeah.
What can I say? Instead of saying one desk and one desk, I could say what? There are two desks, right? So if items are the same type of items, then we can combine or collect them. Okay? And if you think about it, in order to be the same items, that means they have to have the same name, right? And which part of a term are the name? The base and the exponent. Okay? And what's changing is, while ago I had one table and then I added another table to it, so now I have a new number of tables. So the thing that changes is the sign and the coefficient, right? The sign tells us how to combine them, either add them or subtract them, and the base and the coefficient tells you how many you originally started with. Okay? So let's talk about combining like terms. In order to be like terms, they must have the same name. Now that's terminology is a little different, right? I'm going backwards now, but you need to be able to think of it so you know what that means. What does it mean if they have the same name? They have the same what? Which two pieces? The same variable, right? Which we call the base. And what?
On the board.
Oh, did it go away? Yeah, sorry, it's reconnecting now. Does it come back? Okay, so there's going to be a little gap in the recording, but that's okay. So they're going to have in order to be like terms, they have to have the same name, which means the same base. And again, base means the variable part, and the same exponent. But of course, we're not going to have any exponents on ours right now, but again, thinking ahead. And what you're going to do when you're combining them is simply keep the base and exponent. A moment ago when we combined those two tables, did we get new objects? No, they stayed tables, didn't they, or desks? Yeah? So they don't change names, they don't change objects, but what you're going to do is you're going to combine the coefficients. And again, the coefficient simply means the number part, right? And that plus and minus in front are always going to tell you how you're going to combine. If it's plus, you're going to add. If it's minus, you're going to subtract. Now, remember that I haven't seen you guys before this past couple of weeks, so I don't know how much you know about signs, positives and negatives. Have y'all done much work with signs, positive numbers and negative numbers, integers? No, you just use addition and subtraction. Okay, perfect. That's good. Good to know. Perfect. All right, so what we're going to do is we're just going to look at a few things, and all I want you to do is I want you to tell me whether they are like terms or not. We're not going to worry about doing any math with them. Just tell me, are they like or unlike? Okay? So, say for example, I have 3x and 5x. Like terms or unlike terms? Like terms. They're both what kind of terms? X terms, right? So these are both what are called X terms. Excellent. Okay? All right? How about, be careful here, are these like terms or unlike terms? Unlike terms, because this one is an A term, but this one is a what? An AB term. So if you have more than one variable, even though you have some similarities, they have to be exactly alike in order to be considered like terms. So these are unlike terms. Okay? Like terms or unlike terms? They're like terms, right? What kind of terms are these? Yeah, number terms, which are called constants, right? And constants are always like to each other. Okay, good. How about these two terms? Like term or unlike? Yeah, clearly. One is an X term and the other is a Y term, right? So we can tell if terms are like or not by simply looking at their variables. So say you have 7 and -5. Are those like terms or unlike terms? They're like. They're both constant terms. The negative is just telling you that you're going to be subtracting, right? So 7 minus 5, of course, is 2. So they can be combined. So they're both constant terms. Good. So what I'm going to do is I'm going to put some on the board. And we're going to look at a couple of these where we're going to actually have some things to combine. So say, for example, we'll start off pretty easy. Say we have 7a's minus 3a's. First of all, are these like or unlike terms? They're like terms, right? So that means we can combine them. So the 7 is positive, the 3 is a negative, so that means we're actually not adding but subtracting. So what's 7a's minus 3a's going to give me? 4a's. Could that be easier?
Yeah.
Okay. So, couldn't be much easier, yeah? All right. Now, let's look at this one. 3BC plus 4CB. Oops, sorry, that's a little messy there. Are these like terms or unlike terms? One of these has a problem. Can anybody tell me? 3BC is fine. But what's wrong with this one?
It's not an alphabet.
Exactly. And they are indeed like terms, but they're not like, they don't look like it until you've put them in order, right? So what should that be instead of 4CB? 4BC. There you are. So sometimes if you have more than one letter, they may reverse them, making you think that they're not like terms. But if you put them in the correct order, you can see that they are. So what is 3 BCs plus 4 more BCs going to combine to give me? Anybody? 7 BCs. And notice the BC part doesn't change, just the coefficient, right? We still have BCs, but we just have more of them than we started with.
So in like terms, only the coefficient changes.
Exactly. Because remember, you're only going to have more of the same thing or less of the same thing, but you're still going to have the same thing. Yeah? Make sense?
Yeah.
Okay. So, how about these? 2x minus x squared. Like terms or not like terms?
No. Like terms. No.
Oh, I liked your answer better at first.
No,
Go with your gut. What is different? This is an x, but this is not a plain old x, is it? It's an x to the what? X squared. So remember, are 2 and 2 squared the same number?
No.
No. 2 is just 2, but what's 2 squared?
4.
So if you change the exponent, you change the kind of term you have. Even though the x part is the same, they're not like terms because the exponent is different. Remember, it's the base and exponent that tell you what kind of term. Yes, ma'am.
How do you spell
Coefficient? C-O-E-F-F.
Okay. Okay. Thank you.
Got it? No problem. Okay, so can I combine these two terms then? Are they like terms? No, because their exponents are different. So therefore, if they're not like terms, can they be combined?
No.
Absolutely not. Okay? All right, good. Excellent. Now, you could have something like this. How about we have 3a plus 4b minus 2a's plus 7 minus 5. A lot of terms going on here, right? Okay.
You could add some of them, like 3a and 2a, and then leave the rest of it.
Exactly. So some of these are like terms, but not all of them. So in that case, just go through and see the like terms. So the first term is a 3a. Are there any more plain old a terms?
Yeah, 2A.
Yep. 2a's. So those two can be combined. And underlining the like terms before you combine them is a really good skill because there could be more somewhere else, right? So what is 3a's minus 2a's going to leave me with? 1a. And if we have just one of something, do we normally say the one? Nope. So we just put plain old a. Now, I would never count it wrong if you put the 1 there. All right? It's not going to happen. But when you look at it in the book, if you look at or at on Education Perfect or whatever, then it's just going to be plain old a. All right. The next, so we've done with our a terms. So let's just get rid of those. The next term is a b term. Do I have any more b terms up here?
Yes.
You see some more b terms up there? No. So no more b terms. So is the plus 4b going to change? No. So we're just going to bring it down completely unchanged. Now we've done with our b terms. What other kind of terms do we have? Number terms, which are called what? Constants, right? Numbers are constantly the same. So I have positive 7 minus 5, which gives me what? 2. And it's a plus 2, right? Because the 7 is bigger, right? So it's going to be plus 2. And so there is the finished form. So you can have more than one kind of like term in the same problem. Okay? Always make sure to separate them with those pluses or minuses, or else you put them all together, which means, and what would happen if I put them all together like this? Does that mean? I just changed that all to multiplication, right? And that's not what it means. Okay, so be careful. Don't stick things together because it'll change.
It's kind of not really possible to answer a problem. You're just making me simplify.
Exactly. We can simplify it, but we can't solve it because we don't know what A and B are, right?
So you can't solve a problem that has, what's it called?
Right, because these things are called what? Do you remember?
Exponents.
Expressions. There you go. And we know they're expressions because what do they not have?
They don't have the numbers. They don't have what? I don't know.
Equations. No equal sign.
That's right. No equal symbol. And if it doesn't have an equal symbol, then you can't solve it. Now later we're going to get to problems that have equal symbols. Those are called equations, and we'll be able to solve those all day long. And that's going to be a big part of this section. You can't solve expressions, but you can solve equations. Okay?
So you can't solve an algebraic
Expression.
That without.
No, you just can't solve it with it because we don't know what A and B or whatever it is, right?
Can you have like an algebraic problem-solving thing where you find out what the actual number is?
If it's an equation, yes.
Well, that'd be completely pointless.
But it's
then it's making you work extra hard and then giving you the thing on the side.
No, there will also be times when you're going to simplify these the other ways. So what we're going to do is I'm going to write some on the board, and I want y'all to work on them. And then I'm going to get the assessments for those who still have some time to work on, and the rest of you can just work on Education Perfect or something quietly.
What is the point of algebra? Like, why do we have it?
Because it allows you to answer questions that you couldn't answer with simply arithmetic. What number would give me something? So we can make very complex sentences with unknown quantities, which you couldn't do in arithmetic. You can't, and you're seeing very, very, very low-level algebraic skills, right? We're building our skills. So really you can't see the point very much in this, but I can show you where you did. That's algebra, right? How do I know it's algebraic?
Because it
has variables in it, right? We're looking for the area of a what shape? Triangle. So if I gave you, right? So if I gave you this, could you now solve it? You bet you can. Area equals. So this is called evaluating. Okay, we might as well put that on in our terms. Evaluating an expression. You can't solve an expression, and we're going to do lots of work with this as well, but you can evaluate an expression. Now think about the root word of evaluate. What do you think the root word of evaluate is? Value, right? And when we think of values in mathematics, value means a number, right? So that simply means to replace the variable with a given value. Something that you worked on quite a lot when you were doing the measurement sections. So here, what are my values? Value for my base is what? 4, right? And my value for my height is
4.
Also 4. Now I've replaced those letters with those values. I have all numbers, right? Can I do the math now? You bet. And that's called evaluating. Yes?
So you know something is algebra when there is
a variable.
A variable.
Mm-hmm. Any letter at all. Right? So that gives me... Okay, so that gives me a good place to stop. Okay. Now I'll just put some problems on the board for you to work, and then you'll work on some of those, just combining like terms, and then we can work on the assessments for those of you who need to.